Today we're going to look at the group 17 elements, also known as the halogens, right? The halogens, which are the group 17 elements, okay? The first four that we have are fluorine, chlorine, bromine, and iodine, right? They all exist as diatomic substances, right? Under standard conditions in their elemental form. So F2, Cl2, Br2, I2, okay? And we're going to be looking primarily at chlorine, bromine, and iodine. Okay, we don't really study fluorine too much in depth, and we don't study the lower members either. Okay, iodine onwards. So these are the three that we really look at in detail. So chlorine, bromine, and iodine. So we're going to be looking at these three primarily. As I said, we're going to be looking at chlorine, bromine, and iodine. Okay, chlorine is a yellow-green gas at room temperature. Okay, sort of like a pale yellow-green gas. Okay, has a very faint color. Bromine is a red-brown liquid. Right? Sometimes you can just call it a deep red. Okay, it's a very dark sort of red color. Um, that's why we call it red brown. Okay, so it's a red brown, or you could say deep red liquid. Okay, and then iodine is a gray black solid. Okay, it appears sort of like it pretty much looks black. It's a very dark solid. Okay, so gray black solid. Sometimes it'll just be referred to as a black solid or a nearly black solid. Okay, at room temperature. Fluorine has a very pale yellow color. Okay, very faint, even fainter than fluorine. So obviously, we clearly see that um, the appearance gets darker down the group, right? The appearance gets darker down the group. In the vapor form, right, bromine and iodine are very volatile. So when you see a sample of bromine, you're going to see a red brown liquid, but at the same time, you're going to see orange vapors form as well, right? Because it's very volatile, it vaporizes, or it evaporates readily at room temperature and pressure. Okay, so um, we have orange vapors, sometimes also referred to as brown vapors of bromine, right? Depending on how concentrated they are, right? Similarly, in the vapor form, iodine has a purple color, right? So when iodine evaporates, it forms a purple vapor. So obviously at room temperature and pressure, bromine is a liquid. Okay, its boiling point is above room temperature. Same with iodine, right? But iodine sublimes directly. However, you also see the vapor forms at room temperature as well because they're volatile. So given that they're volatile, okay, we're going to see why they're volatile. Okay, so we know that the group 17 elements are volatile. Okay, they're volatile elements, right? And we also know that the volatility would decrease down the group, right? So they're volatile, but volatility decreases down the group. The reason they're volatile is because you have weak van der Waals forces, right? And we know that volatility decreases down the group. Okay? Volatility decreases down the group, or we can say that the melting point, boiling point increases down the group. Okay? Increases down the group. The reason they're volatile is because they have weak van der Waals forces, right? Because they're non-polar molecules, but down the group, obviously, the strength of those intermolecular forces increases. Okay, so down the group, right, what happens is that the van der Waals forces, right, as the number of electrons increases, as the number of electrons increases, we can say that the strength of the van der Waals forces, the strength of the intermolecular van der Waals forces. Okay, I'm going to use VDW for van der Waals forces due to instantaneous induced dipole interactions, right, increases down the group. So the fact that they're non-polar explains why they're volatile, okay? Because they're non-polar molecules, right? It explains why they're volatile, and it also explains their solubility, right? So they are very, very, very partly soluble in water. Okay, so as far as their solubility is concerned, okay, they are barely soluble. Okay, barely soluble in water. Okay, whereas they are much more soluble in organic solvents, right? Um, more soluble in non-polar solvents or organic solvents, right? Such as hexane, for example. So if we talk about their appearance in organic solvents as well as in aqueous solution, right? We can look at this, and we can see here that on top we have the less dense organic solvent, and the bottom we have the aqueous, right? And the water as a solvent, right? So we have the aqueous layer, and we can clearly see that a lot more of the halogen is dissolved in the organic solvent. Okay, so as far as appearance is concerned, okay, as far as appearances are concerned, we can say that what we can say is that when we talk about appearance, right? We can talk about their appearance in organic solvents or non-polar solvents. Okay, so in aqueous solution and in non-polar solvents, right? Non-polar organic solvents, right? So in aqueous solution, you can barely see chlorine, right? Because it actually reacts with water. Okay, whereas bromine will appear as like the appearance of bromine can be described as orange or brown. Okay, it's going to be a very light, faint brown or sort of orangish brown, depending on the concentration. Higher concentration, it'll appear brown. Lower concentration, it'll appear orange. Okay, so in aqueous solution, we don't really talk about chlorine. Okay, as far as bromine is concerned, it'll be sort of an orange slash brown, okay, solution. Okay, and then iodine, okay, appears brown in aqueous solution. Okay, so iodine and bromine have a very similar appearance in aqueous solution. On the other hand, in non-polar solvents, okay, their color is far more visible, right? So chlorine again will appear as a pale yellow-green solution, right, because it has a very pale color. Okay, so it's a pale yellow-green solution. Bromine, on the other hand, will appear as an orange solution, okay, and will be very sort of like a bright orange, as we can see here. Okay, again, this can be described as orange or brown, somewhere in between, whereas iodine will appear as a purple solution.